Hello, I am Erdem from uWisdom. In this video we will find power dissipated by this 2 ohm resistor applying node analysis on this circuit. The first step of node analysis is to choose a ground node, and I'm choosing this node to be the ground. Okay. And second step is to assign unknown node voltages. By the way, this is 3 amps. Let me write that down. You write unknown node voltages. We know voltage of this node, right? Because by going from ground to this node, we have increasing voltage by 5. So this is 5 volts. We don't know voltage of this node, and I'm labeling this as node A and voltage of EA. And I'm seeing that this node A and this node B is connected with a voltage source, right? This means we can construct a super node by combining node A and node B. So I'm constructing my super node like this. Okay? And note that this is terminal A, this is terminal B, and while going from node A to node B, we have increasing voltage by 4Ix. So this node has a voltage of EA, or this terminal, and the left terminal has a voltage of EA plus 4Ix. So this labeling saved us from labeling an unknown terminal voltage or node voltage. Okay. As you see, we need to write one KCL equation because we have only one unknown, that is EA. So KCL at supernode. Firstly, KCL at supernode. There are 1, 2, 3, and 4 currents related to supernode. And the first one is this Ix, right? Ix is away from supernode, that is plus Ix in the equation. We don't know current through this 3 ohm resistor. We are assuming it to be away from supernode, which means voltage across it is EA minus 5. Divide this by 3 to get current value. Remember, we have operated in the A terminal of the supernode. Now we will operate on the B terminal of the supernode, which has voltage of EA plus 4Ix. This 3 amperes is entering to the node, minus 3 in the equation. We don't know current through this 2 ohm resistor. Assume that is away from supernode, away from supernode. And voltage across it is EA plus 4Ix minus 5 divided by 2. And set whole equal to 0. Notice that we have 2 unknowns, right? We need one more equation that includes EA and Ix, or just EA. So observe that in this 5 ohm resistor we can relate Ix and EA. If you divide EA by 5, you can get current value, which is labeled as Ix. So our last equation is EA over 5 is equal to Ix. So I'm setting 5 near Ix. EA is equal to 5 Ix. Then we can write 5Ix every time we see an EA. I am sending the rules out of the screen. I will rearrange this equation. I will multiply every term by 6, and I will write down 5Ix every time I see EA. Okay, 6Ix plus 2 times 5Ix minus 10 minus 16 plus 3 times 5Ix plus 12Ix minus 15 is equal to 0. What we have? 6, 10, this makes 10, 6, 16, 31 and 43. 43ix, right? We have minus 10, minus 28, minus 28, and minus 43. Send it to the other side, we have 43, and ix is found as 1 amps, 1 ampere. We found ix. If we multiply it by 5, we can find EA. Then EA is 5 volts, right? So easy. At the beginning of the video, I told you that we will find power dissipated by this resistor, and we need to find voltage of this node, which is EA plus 4ix. And if you make this summation, you can get 9 volts. With these two values, we can find voltage across it, which is voltage 2 ohm, let me say. 9 minus 5 is equal to 4 volts. And remember the power formula? V squared over R. We know V, which is 4 volts. We know R, which is 2 volts. So let's find power. V squared is just 4 times 4. Divide this by 2 to find power. And that makes 8 watts. Right? Remember what we have found in the last video with mesh analysis? Power dissipated by 2 ohm resistor is found to be 9.68 watts. And they are pretty close but not the same, because we have rounded some numbers here, and when you take the square of that rounded numbers, the delta increases. So we have found we couldn't find actually the same result, but they are pretty close. But what I want to say is that in this analysis we have solved 2 equations, but this is like a half equation, so this makes 1.5 equation. And in this analysis, mesh analysis, we have solved exactly 2 equations. So what I want to tell you is that please try to observe the circuit at first, and then decide which analysis you want to use. Okay? You can decide it according to what is asked, or which one gives you less equations. So try to mix them up and decide which method you want to use. That's all for this video. Thanks for watching.